Now, please welcome John G. Clark, Senior Vice President of Technology and Strategic Innovation at Lockheed Martin, for a tech talk on National Proving Ground for AI.
Good afternoon. Name is John Clark. And I will highlight for all of you that I anticipated I might be able to see the audience a little bit better than I can, but the lights are bright enough that past the first row, I don't know how many people are out there, so bear with me. So I've been operating in the artificial intelligence space now for about 20 years. Began doing neural network-related research in the Skunk Works in 2005 to 2007. And then continue to expand that related work in the autonomy space over the course of the next 10 years. And have continued to advance these types of technologies along the way. One of the more entertaining activities that I was a part of was looking at, in 2018, we wanted to explore, could we use artificial intelligence to go into an RF environment that was completely unknown to the systems that we're bringing in there, and could those systems rapidly and dynamically figure out all the different threats that are out there without any a priori knowledge, and how well would the artificial intelligence perform in that environment. And we were successful at identifying a lot of core technologies that we then proceeded forward and launched into a variety of systems that we have today. As a part of my overall career activities, progressing through that, I had the opportunity to lead the Skunk Works and pushed a lot of these types of technologies in our environment, looking at how we could advance and disrupt the status quo in the software arena using artificial intelligence. Now, one of the interesting things that we looked at is that how do we apply this technology to current systems with current processes with current limitations of our DoD acquisition environment. And we pioneered a number of ways in which to go do this in terms of a test environment and exploring that different environment. So much so that we're now applying these technologies to the F-35, where we're looking at how do we take what is called the mission data file, or the MDF, and how do we dynamically adapt that mission data file every day based on what you may see in an adversary environment, and how that needs to update so that the radar or the CNI system or the EW system can respond appropriately to that very dense RF environment in the field. So this is technology that is now moving its way forward through the overall acquisition process. In my new role at the corporate level as the Senior Vice President of Technology and Strategic Innovation, one of the key capabilities that we have within our organization is called the Lake. And with the Lockheed Martin AI Center, or the Lake, we are advancing those technology capabilities across the waterfront, applying artificial intelligence not just into EW-related capabilities, but we're also exploring how we apply it to our communications environment. How do we bridge between the air domain to the sea domain? How do we take that same information, communicate it across satellites, and bridge all that information in such a way that we can make heads or tails of the environment that we're operating in? And so as we continue to advance these technologies, we're finding limitations that are allowing us to focus the next sets of research. It's also giving us opportunities to push the capability into the field, understanding the limitations that are there with the current system, but how we can advance it for immediate warfighter needs. As you look at this ubiquitous, LEO layer that is coming about, how do we take all of the information that's moving across all the satellites, tying it together with the surface level domain and the air domain, and maintain a constant and consistent tracking picture? And so in the context of a different type of fusion than the previous conversation, but how do you do sensor fusion? How do you take the pedigree of any individual track that's come from the network and understand what parameters do you use, what parameters do you throw away? How do you localize so that you can actually get weapon target quality coordinates and operate across all those domains simultaneously? And that experience, as we're building it up, has taken a requirement for us to have a very robust test environment so that we can understand how these AI algorithms are operating and how well they perform in different scenarios under different stressing conditions. And in fact, Lockheed Martin, we made a big bet in 2018 on a verification and validation approach on how we could test artificial intelligence algorithms so that we could identify stochastic performance parameters to understand how well does it operate when, in our traditional DoD ecosystem, determinism is a desired outcome. You want to know that a set of inputs always result in the same set of outputs. Well, with artificial intelligence, you don't always get that benefit. And then how do you go validate or verify, prove a system? And so we started to put a lot of infrastructure in place with our team to understand how do you take and blend that deterministic environment that the entire ecosystem is built upon and translate that into a more stochastic environment that's outcome-based, and you understand the value proposition that's coming across. And we made a lot of significant headway in that. So much so that in the Red Sea, with a lot of the activities that are going on there, we had an operating challenge. So the Iranians decided that they were going to begin, having these barrages of Shahed drones. Well, these Shahed drones, they don't fly very fast. They don't look like traditional airplanes. They don't operate like traditional airplanes. And most of the very capable radars that exist in the environment, they want to take things like that and they want to move them out as clutter. They're obscuring things on the display. And so you're really trying to push those things off to the side. However, these became very important threats that could impact the surface fleet. So in partnership with the Navy, we started to explore how we could apply artificial intelligence to the real-world data that we were getting every day in the threat environment, understand how we could update those radars so that they're seeing all the appropriate things in the environment, and then how would we test it overnight to ensure that what we put forward was going to be the greatest thing for our warfighters so that we didn't risk our naval sailors at any point in time with these updates. And in doing that, we were successfully able to establish a process where today we receive all of the threat environment coming from the Red Sea. We go through our artificial intelligence algorithms. We dynamically adjust a series of gains to understand how to get the most performance out of the radar based on the environment that they're seeing all the time. We then do an over-the-air update that then at the very last mile we do a traditional upload process that aligns with the Aegis weapon system to then put these new capabilities in. And in doing so, we've been able to establish a very solid foundation where we're updating these systems every day, the over-the-air update that's allowing them to stay ahead of the adversary, and we've been able to successfully blunt all of the Iranian incoming assets as they've tried to attack our naval surface fleet. And that environment that we use to test and understand how well our stuff is working, we started to think about how could we use this more broadly. And in particular, AI has become so ubiquitous that everybody has the claim that they've got the best AI algorithm. They're going to solve world hunger with their AI. Just buy a license from them and they've got it taken care of. But there's really not an environment that allows everybody to understand how to vet their capabilities. And now with Golden Dome, we've got our national interests in mind with respect to keeping our nation safe. How do we ensure that in a very complex environment, with a lot of our own aircraft flying around, with our own air traffic control radars, all the different systems that operate inside of our domestic theater, how do we ensure that if something incurs that theater, that we can take appropriate action, that we know that it is definitively an adversary action so that we can preemptively combat it? How do we differentiate between blue forces and red forces dynamically? That requires us to have a test and evaluation ground so that all of the algorithms, all these new AI inventions that are coming along, that we can test them properly. So as a Lockheed Martin team, we decided that we would explore how do we go vet all of these new algorithms, all these new capabilities, not just from Lockheed Martin, but from all of industry. How do we ensure that the government is getting the best capability at all times as it's going into their weapon systems, where our Americans can stay safe and our allies can stay safe with the weapon systems that we provide them? So today I'm here to introduce AI Fight Club. AI Fight Club is going to be an arena using all of the test tools and the capabilities that we've established at Lockheed Martin over many decades of testing and evaluating these types of algorithms, all using government-approved and government-sanctioned tools and models that will allow us to explore different AI constructs and determine, does this AI algorithm perform in the way that we expect it to perform? Does it provide a net benefit to the environment? And how do we go compare and contrast that with current processes and procedures? So with AI Fight Club, this arena will allow us to go test individual small algorithms all the way up to weapon system level concepts across an entire theater and evaluate the improvements that we can bring into the system. So with AI Fight Club, we're going to be inviting anybody who wants to pit their AI up against the government environment with our native test and evaluation setup to determine how well their systems are performing. So a lot of these small companies that have great ideas and great AI, but they don't have the capital to support the full test environment and the full ecosystem that underpins it, they can now connect in and tie into our AI Fight Club environment and explore. And true to a fight club, the intent is that what happens inside of that environment will stay within that environment. It'll be the competitor's choice in terms of how much they socialize, how well they did, but they'll be able to take those lessons learned and apply those lessons learned back into their environment and use that as a mechanism to advance their capabilities. And then from the internal perspective, we intend to take all the learnings that we have and apply that into our systems. And so when you look at Lockheed Martin as a defense-only contractor that also does approximately $70 billion in sales annually, that's what we did last year, that translates with about 60% of that $70 billion actually goes into our supply base. And so we're looking for the best of the best to come through our ecosystem while also vetting the things that are out there. We want the best things in our weapon systems. We want the best things for our warfighter. We want the best things for America. And so we're going to use AI Fight Club as a mechanism to help vet those technologies and not just have a glossy marketing brochure and a lot of aspirations or statements made or proclamations by folks that are trying to use AI as a differentiator, but really what underpins it doesn't advance the state of the art. And so we're really excited to introduce AI Fight Club today. How this is going to work is that over the course of the next 3 months, we will finalize the arena based on the contestants that are going to sign up. We will have the first set of competitions in the fourth quarter of this year, and we will continue to explore and expand the environment as we get learnings from each of the contestants or competitors that enter into this environment and explore how the technology that they're bringing in makes a difference in the weapon systems and the fight environment that we operate in every day. So we're really excited to have everybody participate. You can see the website here listed above. It is active and live. We look forward to whether you're a DoD traditional entity or you are a small commercial entity that has a great idea that you think you can go help national security. We invite you to participate in AI Fight Club and advance your capabilities for our national security. Thank you very much.